In this part two, we are going to look at some more complex compounds for ionic bonding, and these are going to be polyatomic ions. So there are some more complex ions out there. These are known as the polyatomic ions, and they are generally made of metal and a small group of oxygens. So here's what I'm talking about. We break them into cations and anions, and there's only one cation we generally deal with. It is this one, made up of one nitrogen, four hydrogens, and has a +1 charge to it. It is called ammonium. So if you see that molecule, you call it ammonium. As for the cations, there's a whole bunch of them, but we're going to focus on 5 of them in this course. First one we're going to look at is nitrate, made of one nitrogen and 3 oxygens, and has a -1 charge. And again, you'll notice that it has an ending that ends in 8, nitrate. That's different from every molecule we've looked at up to this point that ended in an IDE. In fact, a bunch of these end in 8. So the next one is known as a carbonate. 3 oxygens, 1 carbon, and has a -2 charge. Next one on the list is a sulfate, also has a -2 charge. This time it has 4 oxygens. And kind of the fourth one of this group is PO4 with a -3 charge, called a sulfate. Now there's a fifth one that's a little bit different. It is made up of 1 oxygen, 1 hydrogen, and has a -1 charge. It is called a hydroxide. So different ending, IDE ending, but like I said, these are the 5 we're going to focus on in this course. In fact, let's take a look at how these interact with metals and bond. So ionic compounds, we're going to use the crossover method to do this. Show the formula of a compound created when sodium reacts with nitrate. So let's write our sodium first. Look up its charge, +1. Next we'll write the nitrate, NO3 with a -1 charge. So they each have charges of 1. So when we cross them over, all that's going to mean is that we end up with 1 of each. We end up with 1 sodium and 1 nitrate. And we call this thing sodium nitrate. That's about as easy as they get. So maybe we should make this a little bit harder. This time let's deal with what happens when iron 2 and phosphate bond together. So iron has a charge of +2 because I said that in the question right there. It could have been +3, but I indicated it as +2. And you look up phosphate, it's made up of 1 phosphorus, 4 oxygens, and has a -3 charge to it. So if we're going to figure out the formula of this, I think the first thing we should do is write the iron and also write the PO4. Now we need to figure out how many irons there are going to be. So to figure out the irons, we need to look at the number that is with the phosphate. That's going to come down, and it's going to give us 3 irons. And then to figure out how many phosphates we're going to have, all we need to do is we need to look at the number up with iron, which is 2, and we're going to bring it down. Now, there's one little complicated thing, and that's that what we need to do is we actually need to put a bracket around this PO4, because this 2 tells us that there are 2 of these phosphates. So inside the bracket we have our phosphate and our 4 oxygens, but then we have this 2 outside. It kind of doubles everything inside. And if you had to name this one, you would name it iron 2 phosphate. So why don't we finish this video up here with a few examples here. So let's start with copper 1 nitrate. So if you were going to do this copper 1 nitrate, the first thing you would do would be to write down your 2 ions, which would be copper and nitrate. Noticing they each have a charge of 1, that should result in a pretty simple formula of CuNO3. That shouldn't be too tricky. Well, what if I give you this one? Made of zinc and this OH molecule. Well, working backwards, the first thing I would do would be to figure out that, well, zinc has a charge of +2. You check that out, periodic table to confirm it. And then we also have this OH, which is our hydroxide, and it has a charge of -1. Now, last thing we're going to do is name this. Now, just because zinc's in the middle of the periodic table doesn't mean it needs a Roman numeral. In fact, if you look up its charge, it only has 1 charge of +2. So you would never need a Roman numeral because you always know the charge is +2. Thus, your formula will be zinc hydroxide. And to finish this off, let's try one with the cation ammonium sulfide. So your first thought should be to write the ammonium molecule, NH4 +1, and sulfide is sulfur, not to be confused with sulfate, so S -2. And when you go to create your formula here, you're going to cross this over, and we should end up with 2 of these ammoniums and only 1 of the sulfurs. So NH4 bracket, there's your 2, and then 1 sulfur. So with that, you can go ahead and complete the homework sheet.